combat laser from the future is already in service with the United States. Laser, light amplification by stimulated emission of radiation. As is known, a laser is an optical quantum generator that converts pump energy into the energy of a coherent, monochromatic, polarized, and narrowly directed radiation flux. Direct Energy Maneuver Short-Range Air Defense, DEM SHORAD. In simple terms, protons excited by an electric current emit energy in the form of light. This light is collected in a beam. Thus, laser beams are generated. The laser beam hits the target surface and heats the material in a spot. Due to the release of heat, the material in the contact area is destroyed or completely evaporates. Various designs of lasers make it possible to obtain, at the output, radiation of different wavelengths, from soft X-rays to infrared radiation. With regard to military applications, this means the ability to choose a laser with a radiation wavelength that is minimally absorbed by the atmosphere. An important element of the laser is the beam focusing system. The smaller the spot area on the target, the higher the specific power that can damage the object. When shooting at long range, the guidance system must compensate for atmospheric distortion. For this, several lasers for various purposes can be used in the guidance system, which helps the main laser to hit the target accurately. That is, low-power light beams are collected into a single beam. What lasers have received priority development in the field of weapons? Due to the absence of powerful sources of optical pumping, gas dynamic and chemical lasers have become widespread. Remember the U.S. Strategic Defense Initiative (SDI) program? As part of this program, it was supposed to install laser weapons on the ground and in space to counter Soviet intercontinental ballistic missiles, ICBMs. Recall that ICBMs are missiles with nuclear warheads, which are designed to destroy strategically important targets at long distances. To destroy them, nuclear-pumped lasers emitting in the X-ray range or chemical lasers with a power of up to 20 megawatts were supposed to be used. The place of combat duty for such lasers would be the Earth's orbit. But the SDI program faced numerous technical difficulties and was canceled. However, taxpayers' time and money were well spent. Some of the research carried out within the framework of the program has made it possible to obtain sufficiently powerful lasers. So in 1985, a deuterium fluoride laser with an output power of 2.2 megawatts of American design destroyed a liquid propellant ballistic missile fixed 1 kilometer away. The contact lasted 12 seconds. As a result of irradiation, the walls of the rocket body lost their strength and were destroyed. This was the most powerful continuous laser at the time. Laser technology also developed in the USSR. In the 1980s, work was underway to create the SCIF orbital platform with a 100 kilowatt gas dynamic combat laser. In 1987, the platform mock-up was even launched into Earth's orbit, but due to a number of errors, the device did not reach the calculated trajectory and was sunk in the Pacific Ocean. The collapse of the USSR put an end to this and similar projects, but not forever. Laser systems today fall into two broad categories. The first includes lasers capable of striking sights and other optical sensors or devices that have become an important part of modern military technology. The second type of lasers is designed to combat unguided missiles, drones, and other flying objects. It is the damaging systems that are of greatest interest to the military. Therefore, there has been significant progress in this direction. Laser weapons are becoming more and more efficient, and energy sources are becoming more compact. In 2002, the American Institute DARPA included lasers in a promising program for the development of space weapons, L.A.Z.E.R, High Energy Liquid Laser Area Defense System. In Russia, a similar project is called Peresvet. The name uses a play on words. On the one hand, Peresvet is a strong radiation, and on the other, the name Peresvet belongs to a Russian hero, a monk, a hero of the Kulikovo battle with Mongolian troops. Recently, there has been a tendency in Russia to name weapons by the names of semi-mythical characters. Today, more than 10 countries possess laser weapons. In addition to the United States and Russia, Great Britain, Germany, Israel, India, China, North Korea, Turkey, France, and Japan announced the creation of their own combat lasers. The DPRK's laser weapons come as a surprise to the United States. Iran has recently joined the Laser Weapons Club. According to experts, Iran has weapons that are capable of hitting stealth aircraft. This seems to be a slight exaggeration, but in any case, the question of the mass use of laser guns is only a matter of time. In the United States, they pin their hopes on combat lasers as weapons capable of stopping Russian intercontinental ballistic missiles, ICBMs, as well as countering hypersonic weapons such as Avangard and Sarmat. However, this is a promising weapon. But in a hybrid war, attack drones pose a significant threat. During the Russian invasion of Ukraine in 2014, American experts witnessed a deadly strike by Russian drones. And after a short war in Nagorno-Karabakh, where Azerbaijan successfully used drones against pro-Armenian forces, the Pentagon urgently began to rebuild its short-range air defense units, SHORAD. It is a group of anti-aircraft and tactical weapons that counter air threats at low altitude. Development of the Direct Energy Maneuver Short-Range Air Defense (DEM SHORAD) project started in 2019. Its goal was to create a short-range self-propelled air defense system with a 50-kilowatt laser on the Stryker chassis. Why Stryker? The Stryker is an 8x84 armored combat vehicle manufactured by the American company General Dynamics Land Systems. The armored hull can withstand shelling from armor-piercing bullets and shrapnel hits from 6-inch shells. It is possible to apply additional protection with hinged armored sheets. From October 2003 to 2011, the Stryker was used in operations in Iraq. According to the paratroopers, this is a fantastic car. There are statistics for one vehicle, the crew of which actively participated in combat operations. During the fighting, Stryker received 115 hits. Not a single grenade fired from an RPG pierced the hull. The armor perfectly resists machine gun fire. Not a single soldier was injured. In short, the Stryker is the best machine in the U.S. Army's mechanized brigades. Two companies participated in the development, Raytheon and Northrop Grumman. The Northrop Grumman sample was eliminated from the competition. The tests were canceled due to problems in the laser power supply and cooling systems. The fact is that a combat laser and associated equipment are distinguished by high heat losses. Only a third of the power is converted into directional radiation, and the rest has to be released into the atmosphere. Accordingly, a 50-kilowatt laser requires cooling systems that can dissipate about 100 kilowatts. Probably Northrop Grumman engineers did not deal with this problem. As for the complex DEM SHORAD from Raytheon, it is also made on the serial Stryker chassis. In addition to the laser, there is an automatic cannon on board. Inside and outside the armored hull, there are power supplies, crew jobs, and part of the control systems. On the roof, above this problem. As for the complex DEM SHORAD from Raytheon, it is also made on the serial Stryker chassis. In addition to the laser, there is an automatic cannon on board. Inside and outside the armored hull, there are power supplies, crew jobs, and part of the control systems. On the roof, above the troop compartment, a combat module with a laser and an optical radar station were placed. A whole battery of radiators and cooling fans is installed on the right side of the case. Gasoline generators provide power. Recall that a significant part of the energy is spent on cooling. During the tests, several types of unmanned aerial vehicles were used as targets. The main methods of using UAVs and high-precision weapons, which have developed to date, were simulated. They also practiced countering artillery and mortar shelling. A total of 12 application scenarios were considered. The complex showed high tactical and technical characteristics that met the customer's requirements. The work will continue. The main direction is to increase the laser power. Raytheon is no stranger to this business. Back in 2010, at the Farnborough Air Show, Raytheon presented a concept of the L.A.Z.E.R laser weapon system combat laser. Back then, the L.A.Z.E.R laser installation was offered in a single complex with the Mark 15 naval anti-aircraft gun. In 2017 trials, L.A.Z.E.R was unable to hit a composite drone at a distance of about 1.8 miles. The power of the L.A.Z.E.R laser was 20 kilowatts. The beam burned through a 1.5-inch armored plate, although at a short distance. The L.A.Z.E.R laser power is noticeably higher, 50 kilowatts. This is enough to counter reconnaissance drones and attack UAVs. According to some reports, the first samples of L.A.Z.E.R have already been deployed in Europe, in Germany. This happened 1 year earlier than planned. In the future, the combat mission of L.A.Z.E.R looks like this. Using an onboard optical location station or external target designation, L.A.Z.E.R must find an air target, take it for tracking, and fire a shot. Power of 50 kilowatts is enough to burn through plastic and metal structural elements of aircraft or ammunition. Tests have confirmed that this is now a reality. Local conflicts, gray areas, and demarcation lines are considered ideal locations for such systems. It can also be used in mountainous areas. In the near future, we will likely see L.A.Z.E.R systems in the Middle East and eastern Ukraine, where ideal conditions have developed for the use of a short-range self-propelled air defense system with a laser.